Uh, Hi everyone. Very good afternoon and a warm welcome to each and everyone in this masterclass by Coding Ninjas in association with Naukri.com. So before starting our session for today, guys, I just have I'll just be reading out a quick statement which was given by NVIDIA's CEO, which says you won't lose your job to AI, you'll lose it to someone who knows how to use AI. So for that sake, this session has been brought to you by Coding Ninjas once again in association with Naukri.com. This session is a free trial of Coding Ninjas advanced certification program in Gen AI and multi-agent systems. If we talk about the speaker for today's session will be Saurav Prateek. He'll be the one who will be walking us through the session, through the demo, as well as how and why one should become a Gen AI developer. So before starting up the session, to all the participants who has already joined, if you want any of your friends, family members, colleagues, or anyone to be the part of this session, you can share in the same link that you've received over mail, over your WhatsApp, and they'll be able to join using the same link. So for that reason, since we are expecting a bit of more participation, we'll be waiting for another 30 seconds. Till then, keep sharing the link, guys. Get your people joined, and then we'll be starting our masterclass in next 30 seconds to 1 minute. Okay, so that's great. It seems like the people that you have shared in the links with have already joined. And at the same time, I would now welcome Saurav into the masterclass and request you to take on this session from here. So, handling it over to you now, Mr. Saurav Prateek.
Hey, thank you. Hello, everyone. I hope I am visible and audible to everyone. Okay, awesome. So, I see a good amount of attendance here. Let's keep the session interactive as much as possible. So, if you think anything is off, you're unable to see me, my voice is not clear, feel free to put that in the comments. Feel free to engage with me through questions and answers in the comments as well. So let's keep this engaging. This will be a fun-filled session. And before that, let me introduce myself. My name is Saurav Prateek. I'm a web solutions engineer at Google, working with Google from past 4 years. And yeah, this session will be about building a ChatGPT-like search using RAG. So we will be using RAG, which is Retrieval Augmented Generation System. Along with that, we will also see how you can ask your large language model to perform a web search and get the results from there as well as a tool. So we'll understand all these. We'll also in the process we'll see how you can build an agentic workflow end to end with humans in the loop. So this is what the agenda of the session is. I'm gonna quickly go ahead and share the tab. Here we go. Okay, let me start the presenter view. Okay, cool. I hope my screen is visible to each and every one of you. Okay, awesome, perfect. So again, this isn't just another free session. By the end of this, you will have something to showcase on GitHub and LinkedIn, and more importantly, a mindset shift on how AI is reshaping the role of the developers. So, quick note: are you actively job hunting right now? If yes, drop a yes or a no in the chat. Also, let me know your current role plus what you are hoping to learn so I can tailor the parts of today's session for you. So I can see a lot of people. Okay, there's a mix of response. I guess majority of people are looking for a job change. If you're typing yes, you can also type your role which you're looking for. Okay, lead data engineer. That's nice. software developer, data engineer, ML engineer. Okay, cool. Senior software engineer, great. A lot of technical roles. So I just want to clarify that um, if you're looking for ML engineer or AI engineer role, then like this would be like a great help. This would be a great help for you. Like this would gonna help you a lot this session. But even if people are looking going forward with a software engineer or looking for a data engineering role, this will gonna help because in most of these technical roles are now, if a person is able to leverage the AI agents and workflow and build end to end and automate a lot of things and as a part of their job, then they like the chance of getting hired, their chance of getting hired increases, their chance of having the productivity, higher productivity increases. So that is why this session is there. And yeah, let's quickly move ahead. So let's talk about the agenda for a minute. We'll start with looking at what is the current industry demand and the need for GenAI. We'll also see the introduction of LangChain and LangGraph. So here we'll be building an agentic workflow. And in order to build this agentic workflow, we'll be using an open source orchestration framework. I guess you must have heard of it. It is called LangChain. And there is a subsidiary framework of LangChain, uh, which is called LangGraph. So we'll be using these to build our agentic workflows. We will also understand how you can perform tool calling in LangChain. And after that, we'll actually build our agentic system where we will understand how to build a retrieval augmented generation system and how you can integrate web search capability to your AI agent. So the thing is, if your agent is not able to answer something on their own, then you can give them the capability to perform a web search. So web search meaning they can search through the web and they can give their query and they can get the response from the internet and they can give you that. After that, we'll also understand how to build a vector search or a vector store as a part of a retrieval augmented generation system. And I'll also give you a code walkthrough and a live demo of what agent we'll be building and how it is actually working. And after that, we're gonna see what is the reality of becoming an AI engineer, what should be the roadmap and everything. Okay, your voice is lagging a little bit. That's all right. Um, I'll try to speak a little bit louder, and if it looks like that my voice is breaking, then feel free to put that in the chat. And now, this is all about, by the way, this class is a free demo of Coding Ninja's advanced certification in Gen AI and multi agent systems. So you can think of today as the trailer, and if you like to go with the paid extended version of the program, after watching this session, you can fill the form shared in the chat box. So I'm gonna basically share the form. And before me going ahead and sharing the form, I'll also gonna share what this program is all about. So this is what the program will have, and I will also go ahead and share the form which you can fill. So this is the form which you can fill, and once you fill the form, you can get a chance to connect one-on-one with the Coding Ninjas program experts for a personalized roadmap. Okay, I hope this was clear, and now we'll move forward. So now let's talk about why Gen AI is not optional anymore. So let's face it, like let's get real. The job market isn't changing, it's already changed, and AI isn't knocking anymore. It is sitting at the table rewriting the job description. And LinkedIn shows a 385% year on year spike in the Gen AI roles, and yet 90% of the applicants fail basic Gen AI interviews. You are now competing with developers who build with AI, and CEOs are okay to shrink the teams. So, can you be a part of what's needed next? That's the reality. And you're not just competing with other developers anymore. You are competing with the AI powered developers who build tools faster, smarter, and at scale. And I'm not saying this to scare you, but to show why most devs are being left behind. Because they are mostly stuck in the chat GPT mode, generating poems, not building actual systems. And resume with vague AI enthusiast lines, recruiters ignore them. Companies don't want dabblers, they want deployers, people who build real, usable Gen AI workflows. And yes, you will find thousands of tutorials on YouTube, but no actual roadmap, no feedback, and no end to end structure. And that is the actual gap. And that's exactly where Coding Ninjas has solved in the structured certification program of GenAI and multi-agent systems. So this is the program, and this is, I have shared the summary of the program in the chat. I've also shared the form which you can fill. So if you're interested, you can go ahead and fill it. And we're gonna move ahead. So this is what is happening in the market, and this is wide. This isn't a trend; it's the new standard. Generative AI is reshaping the global economy, and India is leading the way. And this program is your opportunity to be a part of that change. And there is a lot of content on this slide, so I'm gonna wait for like maybe 10 to 12 seconds for like everyone to let that sink in. Okay, awesome. Let's move ahead. So, where developers are heading, and the developers ally, AI is not going to replace programmers, but programmers who use AI will replace those who don't. These roles didn't exist 2 years ago, and today they are among the highest paid. We'll be simulating how a GenAI engineer builds today live in this session. Let's gonna move forward. And now let's talk about what we are actually building. So, like actually we are building a retrieval augmented generation system with the web search capability. And this isn't a project, it's a real world demo used inside the full certification program by the Coding Ninjas. And I've already shared the program and the form, so you can go ahead and fill and you can get a chance to connect one-on-one with the experts for a personalized roadmap. And now let's talk about what we are actually building. So I mentioned already that we are building an agentic system which will be implementing retrieval augmented generation along with a web search capability. And to build that, we will be using LangChain and LangGraph. So how many of you have heard of LangChain or LangGraph before? If yes, you can type yes in the comments so that I can understand how many people have actually like an idea about this framework. Mhm. Okay, I can see a couple of responses, and there's a mixed response. I guess there is a 50-50 response. A lot of people have heard about it, a lot of people have not heard about it, and that's all right. But if you are trying to build an agentic system or complex agentic workflow, this is one of the hottest technologies to go with. This is also one of the hottest startup currently ranked. I guess it was ranked second or third in the world's hottest startup, that is LangChain. So you should you should definitely give it a try. It's great and it's actually very efficient for building an agentic workflows. So LangChain, what is LangChain actually? It's a framework with which you can build with large language models by chaining interoperable components. So basically what you can do is that when you use ChatGPT, you are already talking one-on-one with the large language models. You can ask question and they can give you answer. That is the only thing which you can do. But what if you want to build more complex systems? Suppose you want to automate something. Suppose you want to build an agent which can like go through your LinkedIn profile and it can give you real time updates on how you can improve or what is lacking in your profile, right? These kind of systems are kind of tough to develop and you will need a lot more complexity, and that's where LangChain comes in. So what you can do with this is that you can actually talk to large language models with this framework, and on top of that you can do a lot more things. You can give a lot more power to your large language models like tool calling, shared state, structured output, structured inputs, and parallel executions, and a lot of things are there. And let's talk about LangGraph for a minute. LangGraph is also a framework by LangChain, and it is also used for building controllable agentic workflows. So LangGraph is actually used for building the agentic workflows, and it's a framework by LangChain, and it lays out the concept of building a workflow in the form of a graph. And since I guess most of the people here are from the computer science background, so they must have heard of graph data structure. It leverages that data structure to build an agentic workflow. I hope that is clear. If there is any question, shall we get any document for this session? You will not get any document, but I'm gonna go through the agentic workflow. We're gonna also see the code. I'm gonna walk you through the code base line by line. function by function so that you can understand what is there. And at the end of the session, if you still feel that you need the code, I can give you my GitHub link, or basically the GitHub link to the repo where you can find all the code bases, right? So that should be, I guess that should be okay. And yeah, uh, let's move forward. So let's talk about LangGraph. We have already talked about LangGraph a bit. Is that LangGraph is a framework for building stateful multi-actor application with large language model, and it is used to create agent and multi-agent workflows. Now, how you can build agentic workflows through LangGraph? So basically, in order to build that, you need to understand the concept of a graph database. So or a graph data structure. So graph data structure has nodes and edges, and a graph is nothing but a connection of nodes through edges, right? Multiple nodes are connected through edges, and in this way, the nodes can talk to each other, or a control flow can move from one node to another. And LangGraph uses or leverages this concept. You can build your agentic workflow where each agent can be a node, and the control flow moves through the workflow via edges. So nodes can be connected through edges and the control flow moves. And in LangGraph, the edges are always directional, so there is a direction defined that in which direction the edges will move. So uh, there will always be a direction, so that a, a strict control flow is determined, and the control flow always moves through that edges from one direction to another. So it's, you can think of it as a directional or a directed edge graph, right? And that is what a uh, LangGraph powered agentic workflow is. We're gonna actually see how you can build that in practice going ahead. But yeah, for now, let's concentrate on this concept for a while. Okay. Um, One more question: how can we add about this session in our resume or in certificate? So uh, basically, you shouldn't add this session as in your resume. It's better, like whatever we are showing or whatever I am walking you through, if you can actually build that on your own, then it would be a good project to showcase on your resume or on LinkedIn, right? So that is the thing, that is what I mean when I say that you have at the end of the session you have something to showcase on your LinkedIn or GitHub. There is no certificate to this because like you are not coding with me. I'm just delivering the session to you. So if at the end of the session you are able to, like, you think that you can build this, then you can go ahead and build this workflow and you can add that in your resume as a project. Um, okay, one more question. What node contains here? Some real-time example. So the node, you can think of a node as an agent doing something, some actual unit of work. So suppose you can think that if you want an agent to go through your LinkedIn profile through a URL and get the content of your profile, you can put that in a node. That node will be an AI agent that will gonna get to your LinkedIn profile and grab all the content. That is one unit of work, and you can wrap that in a node. And then there can be another node which, like you can, which the previous node can transfer the content and they can do something on that content, right? So in this way, you can arrange your agentic workflow. I hope you got the gist of it. Okay, one more question by Jaya. Sorry, I joined a little late. Did I miss the major part? No, actually not. We are just getting started. I was explaining the LangGraph and LangChain concepts. That is the open source framework which we're gonna use to build the agentic workflow. Okay. Can we use any tool for this? I don't understand this much. So yeah, feel free to put your questions and I'll try to answer, and let's move forward. Okay. Let's talk about the LangGraph concepts. So there are three concepts which I want to highlight here. First is internal shared state, then nodes, and then edges. So let's talk about nodes first. So nodes are independent agents that perform a unit of work or a collection of tasks and update the internal shared state of the graph. Now the thing is, when you are building agentic workflows in LangGraph, you need for your nodes to talk to each other. And in order to talk to each other, they should be able to pass information from one node to another. Otherwise, there is no way they can talk, right? So if a node want to send or tell something to another node, they have to send something, some data to the another node, and that is done using a shared state. So you can think of shared state as a box where one node can fill the information and can send it to another node, and the another node can take the shared state that is the box and open it and get the information whatever the previous node has stored, right? So a node can perform an independent task or a unit of work, and whatever result they achieve by completing that work, they can put that in a shared state, and they can move it along the control flow through the graph, and whatever node is lying ahead, they can get that shared state, and then they get utilize that information. So that is what the concept of nodes is. Then let's talk about edges. Now, edges connect two nodes in the graph, and they create a flow of the graph execution. And always understand that in a line graph, the agentic workflow is a directed acyclic graph. That is, the edges are always in a direction, and there is no cycles in the graph generally. So there is the edges are always directed. There will be a specified directions, and the edges in a line graph or in your agentic workflow will gonna determine how the control flow of your agentic workflow should look like, right? And lastly, internal shared state. Each graph execution creates a state that is passed between the nodes in the graph as they execute. So again, the internal shared state, you can think of it as a box where you can fill some information, and those information are shared between the nodes in all of the graph, right? So if a node want to talk to other nodes, they can do that using the internal shared state. And we'll be using the internal shared state in our code walkthrough and when we are building the agent uh, ahead. Okay, Nikita is asking if I join only this session, so will it be enough for me to build a project? So we are walking through one of the project which will be a part of this curriculum, the Coding Ninjas curriculum. And yes, whatever this agentic workflow which I am walking through is an end-to-end. So if you are willing to attend this session, full session completely, full 1 hour session, then yes, you should be able by the end of the session you should be able to build this project. Is there other framework to develop RAG? There are other frameworks as well, but I haven't seen any of them getting as much popular as LangGraph. A lot of companies who build their large language models like OpenAI, Google, Meta are coming up with their own frameworks, own in-house framework where you can use their model and build retrieval augmented like RAG framework and other things. But uh, the positive thing or the advantage with LangChain is that you can use a lot of a large language model. You can select between a lot of models. You have a lot of options. You can have like Gemini models. You can have Llama models. You can have OpenAI GPT models. You can use Grok. A lot of integrations are there, and that's where I have seen a lot of people using this. Okay, I hope this is clear, and let's move forward because we have a lot of things to cover. So I'm going to quickly touch upon this one of this concept that is called tool calling, because we'll be using this to provide web search capability to our agentic workflow. So tool calling is nothing is like is a concept where we give large language model some tools which they can perform, and is a concept where large language models can understand the human message, and on the basis of the context they can decide which tool to call with the right parameters. Okay. Um, I'm not sure about the meeting link, Sovik is asking. So, moderators, if you are there, if you can share the meeting link and help them out, that would be awesome. Yeah, moving back to the session. So, yeah, we are talking about tool calling. So, the thing is, the tool calling provides your large language model ability to perform a lot of things. So, suppose you have your dedicated business logic, which you want your large language model to perform at a certain situation, then you can give that as a tool to your large language model and can tell them that, hey, this is a tool, this is the input parameters through which you can call this tool. Now it's up to you. Whenever you think you need to call this tool, you can go ahead and call it, right? And that is what the overall idea of a tool calling is. So here in this diagram, a user is giving a human message to the large language model, and this model is calling two tools, tool 1 and tool 2, depending upon the use case. They are getting the response and then they are sending the AI response back to the user. Now let's talk about some general real world scenarios where you can leverage tool calling. Is tool calling a general concept or something specific to LangGraph? So, tool calling can be done in LangChain LangGraph, but it is a very general concept. It is used in the large language models like OpenAI, GPT models as well. One of the classic example is the mathematical calculations. Large language models are nothing but the next word prediction or next token prediction workflows which can predict next word which is coming, and through that they can generate the context. On top of that, there is some fine tuning done so that you can get a chat model, right? But they are not very efficient in performing mathematical calculations and expression, and for that they perform tool calling. So you can, like, GPT can have a calculator as a tool which they can use when they think that okay, you are asking something mathematical and it would be very complex for them to answer that. They can use that as a tool, and it is actually being used in a lot of large language models. The thing is, you're not able to see that, but it is a uh, very wide term being used, and it is used in research papers as well. If you can, like, go through the GPT-3 or GPT-4 papers, you can find the traces of tool calling being done for making these kind of model very advanced. Because if you see the old GPT-2 or GPT-1 models, it was not that advanced. And if you can, like, if you ask natural language question that hey, how are you doing, how are things, they can answer that. But at that time, if you would have asked like 3 4 years back that hey, what is 555 into 616, they would hallucinate and they would give something junk to you. But now this is getting being fixed using tool calling, all thanks to tool calling, where you can provide a lot of tools to your large language model which they can use when they think that they have, like, they have the reason or they have the uh, ask from the human, right? um, I hope that answers the tool calling. Yeah. Cool. We will see this tool calling in action. This is one of the classic examples where I have an AI agent and I'll try to give two tools. The first tool is to add two numbers, and the second tool is to get the length of the string. So it is very descriptive. Add two numbers, take two numbers as an input and adds them and return the number. Get length of the string gets the string as an input and returns the length of the string. And this is how the tool looks like. It has a name, which is add. The description is add two integers. The schema takes a and b, the two number, as an input, and it returns a plus b. Now the length tool, uh, the name suggests find length. It finds the length of the string. The schema takes string as an input and returns the length of the string. Now, I provided these two tools to my large language model, and I tried to ask some question. So my question was to the large language model was add number 5 and 4 and also find the length of the string crocodile. Now the thing is, you can ask these questions to GPT, ChatGPT, and Gemini, and any other uh, model, and they'll be able to answer that, because this is a very general question and they should be able to answer that. But I just want to clarify that this, like, they understand tool calling, and if you give them the tools and they see that there is some question which can be solved through that tool calling, they're gonna give that the preference. So here my GPT, I'm using a GPT model, GPT-4 model. What it is trying to do is that it is performing tool calls, and there are two tools call which it has performed. You can see that in the right side. The first one is the function is name add, and you can see that the first function is name add. The arguments are 5 and 4, and for the second one, the index one, the function is find length and the string is crocodile. So from your natural language, so asked was what I asked was find the, sorry, let me zoom it up. What I asked was add number 5 and 4 and also find the length of the string crocodile. So that was a natural language. The large language model took the prompt and identified that hey, the user is asking me to add 5 and 4 and I have a tool for it. So maybe I can use that tool with input 5 and 4. And the user is also want The user also want to find me the length of string crocodile. I have also a tool for it, which is find length. So I can give the input crocodile and get the answer. And after that, they execute these tool calls and they came up with the answer that the sum of 5 and 4 is 9 and the length of the string crocodile is also 9. So this is how you can we can be sure that our tool call is actually being performed. Now you can do a lot more difficult things using tool calls. You can give a lot. Maybe you can give an entire collection of APIs to large language model and tell them to call any of them with the request parameters depending upon whatever user is saying, and you can automate a lot of things in the software world. Okay, now this was all about tool calling. There is a lot of questions as well. Let me answer. Will the current session recording shared? I think the recording will be there on YouTube or somewhere, so you can always find that. How does the LLM understand what tool to use where? So the LLM tries to understand the tool with the help of your context and the description of the tool. So you will see that the tool which I have given, I have also provided the description. So this helps the large language model understand that what this tool is for. So I'm saying that in the description add two integers. So the large language model have the understanding that when I have to add two integers, I can use this tool. So if we provide a description with the tool for the large language model to have the context that what the tool is used for, what is the background of the tool, so that they can further like make a decision on the basis of the user prompt that whether they want to call a tool or not. And yeah, that's how they understand. Okay, one more question by Fanny. If we give prompt for generating image, how it will work? That's actually a good question. So these models are a completely different set of models, although like they work on a same transformer paradigm where the idea is to predict the next token. But here, instead of the token being a character, the tokens are probably pixels in a high dimensional space. So what they can do is that from the context, they can understand what they are actually trying to generate, and they can try to generate something like that. And the same thing goes for audios and videos as well. It all work on the same paradigm of transformer architecture. The only difference is what they are trying to generate. In our case, we are trying to generate tokens which are actual words, but there can be pixels in high dimensional space, or or some kind of sound. All right, so, like something which is tokenized and vectorized, and they're in a high dimensional space for them to understand. And let's not get into that because that's another complex world to go into. Do we need to write all the tools we need to add, or there are any third party support? So there are a lot of general tools available, but generally tool calling, the whole concept of tool calling is that there is something custom needed for your purpose which you want to do, and that's why it's always like makes sense to write your own tool. And in most of the cases, if something is very general, your large language model should be able to do that. But if you think that there is something very custom to you and large language model like might not be able to do that, you can write a tool call for it. Will be in JS or Python? Yes, this will be in Python. The code will gonna look ahead will be in Python. Cool. Okay, great. Let's move forward. Now we have discussed a lot of things about the background. Now let's actually dive into what we're gonna build. So we're gonna build an AI agent. There are the AI agent. In this AI agent, we're gonna look into. So basically, we'll be building an agentic workflow, and in this, we're gonna look into two things. The first is how we can build a retrieval augmented generation, that is a rack system, and as a part of it we'll also see how we'll be building a vector store to support it. And after that we'll see how you can provide web search capability as a tool calling to your large language models as a fallback. So we're going to see both of things. One more question. So LLM include tools? Yes, large language model include tools as a part of their full-fledged product. So you like the large language models are basically once these companies train these large language model, like this is nothing but a you must understand that this is nothing but a deep neural network. Uh, the transformer architecture is a deep neural network, right? And when these are trained, this is nothing but a numbers series of numbers or series of weights, I may say, if there is a 3B or a 3 billion model or a 128 billion model, means there are 128 billion weight parameters in a high dimensional space, which will help the model to predict the next token. That's it. That's what the whole gist is. What these company do is that they, once the training is done, you get a base model. Once they have a base model, they perform fine tuning with a lot of manual uh, work on that, so that they can give you a chat model. So they fine tune that base model so that they are fine tuned to answer your question in a, and then you build a chat model. And with the chat model, they can also have like tool calling. They can also, you can also provide tool calling capabilities so that they can automate a lot of different aspects of things, right? Like uh, tool calling capabilities can be building a website. Like if you want them to build a console, if you want them to build some workflow, or basically building some high level diagrams, calculating something which you always you understand that there is like a fixed set of um, instructions which can be given as a tool. That is basically like that's where tool calling is helpful for these models. And yeah, cool. So we have laid out the context what we'll be doing. We have approximately 30 minutes. So in 30 minutes, let's try to build this. Moving ahead, I would like to first go through the basic rack pipeline. So what is a rack pipeline? Uh, Retrieval augmented generation system is nothing but when you actually ground your large language model on some documents or knowledge base. So every large language model has a knowledge cutoff, and to beat that, you can use RAG, right? There are a lot of actual use case of RAG. There is a lot of document, there is a lot of context which is not available on internet, which can be private. And if you want to perform, or if you want to train your large language model on those documents, then the current large language model will not be able to do that. You have to provide these documents explicitly so that they can like understand that, and maybe in future answer questions on that document. And that is why that's where RAG comes in. Also, large language model has a lot of documents in their mind, and a lot of times if the question is very general and they think that this question can be answered through a lot of different places, you might not get the actual answer you want. And in those situations, maybe you want to specifically tell them that, hey, I know that you have a lot of understanding of the world, but for my specific set of questions, please focus on this document. And if you're able to find the answers in this document, please try to prioritize that. And that's what RAG pipeline is. So what we do is that whatever document we have, that might be internal, or that might be very new document which the large language model have no idea about, we can convert them into vector database. And from that vector database, you get the top most important documents depending upon the user query. And with that, you give those top documents with the query to the large language model, and you get the response. Now this is a very big workflow diagram. You can divide it into two parts. The first one is data indexing, and the second one is data retrieval and generation. Now the data indexing is all about building a vector store. So here what you do is that you get a document, you divide them into small chunks, and you convert those chunks into vector embeddings, and then you store in the vector database. So what you have in the vector database, you have a chunks of vector embeddings, which was earlier was your document. So you converted them into the vector embeddings. Now why vector embeddings? Because large language model is nothing but a deep neural network, and neural networks are good with numbers. They are bad with natural language and other kind of format. They are good with numbers. They are good with small numbers in the range of 0, 1, minus 1, 1, stuff like that. So that's why when we convert these documents, we convert them into embeddings, which is numbers in a high dimensional space for your large language models to understand, right? So in step one, we perform data indexing where we convert your document into the vector database. In the second part, that is data retrieval, what we do is that we pick that vector database, and there suppose you got some query from the user on that document. You don't want your large language model to search on the entire vector database, because that can be pretty huge, and every large language model has a context window. You must know that that is limited. So you cannot put everything into the context window. Think of this context window as a RAM of a computer or a CPU, which is limited. It's small in size, and you cannot put everything, or you cannot load everything in the RAM. What computer does is that it keeps the important information that it requires for that time period in the RAM, and once this is done, they clear the RAM or they empty the RAM for making space for the new information. Similarly, you cannot put everything into the context window of your large language model. So instead of giving the entire vector database, you get the most important documents which you think that might have the answer for your question, and you give those important documents along with your query and hope that large language model will answer your question depending upon the context or the top documents as a response, right? So that is the whole purpose of our RAG pipeline. I hope this is clear. uh, this is what it is. And why are we using a RAG? There are mostly two important cases, or two very normal cases where you can expect to use RAG. The first and foremost is the knowledge cutoff. So the thing is, training this large language model requires a lot of money, a lot of compute power, and that is why these large language models are not trained very frequently. If OpenAI is releasing their GPT-4o model, you can expect that this model is trained maybe on a period of, like within 2 to 3 months, and then maybe they will be trained again after 2 to 3 months. So within that period, a lot of things can happen. So suppose your model was trained in the month of June, and something really important happened in July, and you want your large language model to answer that. So in those scenario, your model will not be able to answer those, and in that case, we have to like give those information to large language model so that they can answer these questions. And that's where your RAG pipeline, or that's where you can build RAG to solve this problem. And this problem is named as a knowledge cutoff, because like the moment the large language model is trained, the knowledge gets cut off till that time period, and whatever is happening after that, your model will not have any idea about it. And at those cases, they can also use tool calling, where if your large language model has a knowledge cutoff, they can go ahead and they can perform a tool search. And that's what your GPT model also does. If they are asking for some information they have no idea about, they might have happened an hour before, they can go ahead and they can they have this tool called a web search capability provided as a tool calling. They can do this tool call and they can get those answers from the web and give it to you. So when you talk to GPT, there is nothing, there is no question that they can't answer. They'll be able to eventually answer each and everything, because they have provided with all these tools, all these capabilities, right? Okay. So now moving forward, uh, yeah, this is the RAG pipeline which we have. I explained this earlier as well. Let's look into it in more detail. The first one is the data indexing, where we are pulling the data, splitting it into chunks, converting into vector embeddings, and building a vector database. In the second one, we are picking the user query and taking the top most important documents from your vector database. And along with those top documents, we are also giving the user query and hoping that the large language model will answer it. Okay, so this is what a RAG is. Now we'll move on to the code walkthrough. I'm gonna like go through each and every code function and we'll see what we can do. One more question: how they handle a large set of data? Is it they maintain Redis or indexing? So the thing is, they don't maintain Redis, they maintain indexing, but the way large language model index document is very different. They index documents through embeddings. Every word, every token, everything which is given to the large language model is first tokenized, is split into multiple small parts and is converted into tokens. And after that, these tokens are given to your large language model so that they can understand, right? So this is how they eventually go through the large set of data and they try to make sense of it. Is there a limit to how much data we can feed to in RAG? So there are two things. There is no limit on the vector database. Your vector database can be as large as you want it to be. because at the end of the day you're doing nothing, you're just converting your text based context into vector embedding. So that is up to you. But another thing, that giving it to the large language model as a context, that's where the limitation is, because every large language model which you use has a context window. You can search about it, what the current model has a context window of, but Gemini model, GPT model, every model you have has a context window, meaning that there is a limit of data these models you can feed into the working memory of these models. So that's where the limitation is, and that's where your capability of picking the top most important documents from that huge vector database comes in. And the better you pick the important documents, the better your large language model will be able to answer on top of it. Okay. One more question by Thanga. In RAG also we are using LLM only, right? Then how can it make a huge difference? It is not making a huge difference. It's just a use case. Suppose you are working in a company. Suppose you are working in a financial company, right? These financial companies has a huge set of data which is not public. So if I tell you that, can you use a large language model to give me some answer on these queries, or like maybe do some processing on the basis of these financial data, these models will not be able to do. You cannot pick a GPT model and can answer and can expect them to answer questions on some very internal data of your company. So in those cases, you have to build a RAG. You have to get those internal data, you have to convert them into vector database, and you have to like make the large language model aware of these data, so that your agent, you can build an agentic workflows, you can build a chatbot on top of it, right? That's where the use case is. It's no difference than a large language model. The only thing is that you are providing them the capability of your knowledge base, any internal, anything specific you want. I hope that clarifies. And yeah, moving on to the code based part. The first part is data indexing. That is how you can convert your normal text context or text content into the vector chunks. So what we have here is that we are getting a document, and this document is nothing but a FAQ document of an airline, of a Swiss airline. So you can expect the documents to have the basic FAQ details of an airline, that is the check-in, the flight schedule, the airport schedules, right? The ticket refund, the ticket booking, all these information will be there. So you're getting that document, and you're getting the content of the document, and after that you are splitting the document into chunks. And then once you have split the document into chunks, you are creating the embedding. So embedding, for creating the embedding, I'm using text embedding small model, and I am inputting the document chunks as an array, and my OpenAI client, or I'm using the large language model to convert that. I'm basically not using a large language model, I'm using the embedding model to convert this content into the embedding. And at the end of this method, I will have the embedding form of my content. So I give the content in natural language, maybe English, and I got the vector embeddings in the form of numbers, right? And this is this number is the thing which the large language model will able to make sense. Now, but another important is getting the relevant document. So once you have built your vector database, it is important to get the relevant documents, because you cannot give the entire vector database to the model, which we have already discussed, right? So what we do is that, depending upon our query, we pick the important documents from the vector database. So we convert our query into the vector embeddings, and then we calculate the similarity score. So we say that, hey, these are the documents in my vector database. I'm going to give similarity score to all these documents to understand how similar these documents are with my query. And then I can pick the top 5 document which has the highest similarity score. And here I am picking top 5. You can pick top k. For me, the value of k is 5. You can go ahead and you can maybe pick top 10 documents. You can experiment through it as well. So what I'm doing, I am picking top 5 documents, and at the end, I'm gonna returning these documents along with their similarity score. And you're gonna understand why I'm returning similarity score as well with the documents, right? So this get relevant doc does nothing but, on the basis of your query, it picks the top 5 important documents. It returns those important documents from the vector store along with their similarity score. Now moving on to the next part. This is the phase 2, the data retrieval and generation. Here we are trying to answer the query. Now, for answering the query, I am using the top 5 relevant documents which I picked up earlier and the user query, and I'm giving both of them to my GPT-4 model, and I'm expecting an answer. So in the context, I'm saying that you are a helpful assistant, and in the context, I am giving the content, which is nothing but the relevant documents. So all the relevant documents which I had, which I picked earlier, I'm giving it as a content, and I'm also giving my query as a question, and I'm saying that you're a helpful assistant. Try to answer this question from the content. So it will gonna use that content to answer it, and at the end we are returning the response. So this is what the entire answer query is. Now we can see what we are actually trying to build here. So we looked into RAG. That's what this is. What we looked into currently. This is the node. Now what can happen is that my RAG can answer a question, or they can not answer the question as well. If my RAG pipeline which I have built is able to answer the question, I can return the answer to the user. If my RAG pipeline is not able to answer, I can perform a web search. So let's keep the thing straight. I build a RAG pipeline using the document from an airline FAQs, right? So these airline FAQs will have the content related to the airlines, right? Flight bookings, flight schedules, airport schedules, and these things, right? So I can ask questions related to that. I can ask question to find the timing of a particular flight that my rack pipeline can answer. But if I go ahead and I'll ask question that how to make a pizza, that it will not able to find very relevant document to answer that, and it will gonna return some vague answer. So for in those cases, I'll use web search. So if my agentic, if my workflow will feel that hey, I cannot answer that, it will gonna use web search and it will gonna return the answer with that. So this is what the thing is. Let's move forward. This is how the web search tool looks like. I'm using Tably Search. It's a very famous what do I say, a software tool. Basically, you can find Tably on web as well. It helps you, or basically uh, it helps you to provide web search capability to your large language model. So with Tably, what you can do is that you have to define how many results you want from the search, and then you have to like provide the argument, your query as an argument, and you have to bind this tool with your large language model, and then you can expect the search result. So what I'm doing is that the model which I have, I am binding this model generated tool call with my tool, and whatever tool message is returning, I'm getting that. So Tavily, if your model is not able to answer, then this tool will be able to search the web and return the answer on behalf of your workflow. Okay, I hope this is understandable. And now let's come to this structure. Now I told you that we were returning the relevant documents, but along with the relevant documents, we are also returning the similarity score. Now here is the reason why are we returning the similarity score, because we want to make a decision that whether we got top documents or relevant documents or not. And how I will identify that? All the documents which I get from my vector database, all the relevant documents which I get, basically I'm getting top 5 relevant documents. So for all those top 5 documents, I have also returned the similarity score. So I will see that if my similarity score is greater than the score threshold. And for me, for this workflow, the score threshold is 30%. So at least the threshold score of the relevant document should be greater than 30% for my workflow to think that okay, there are some relevant documents. So I'm going to filter that, and even after that, if there is some documents which I got as a response, I can safely say that okay, my RAG pipeline can answer that. If not, then I can perform the web search. So that is the whole reason I was getting the score or the similarity score. This is how the code look like. At the top, I have the score threshold, which is 30%, that is 0.30. And for all the doc similarity scores, I'm getting the relevant document. So basically what I'm doing is that for every page content, I am checking the similarity score of each and every doc, and I'm filtering out if the similarity score of the doc is greater than the score threshold. Then I am putting them in a filtered relevant doc. After that, I am checking the length of the filtered relevant doc, meaning that my filtered relevant doc has anything or not. If there is something, meaning that there are some docs which has similarity score of more than 30%, then I can use my RAG pipeline to answer using the answer query method which we defined earlier. If not, then it means that there is no relevant documents with the sufficient similarity score, and I'll call perform web search, which we mentioned earlier as well. We can give them the query and we can return the search result. So both the cases we will get something, but we do that on the basis of the similarity score. Okay, now this is what it is. Before moving on to the slides above, let me quickly walk you through the code, because I promised that I'm gonna uh, give you the code walkthrough. So I'm gonna quickly stop sharing. I'm gonna share again my entire tab, and this time the code walkthrough. Okay, awesome. You're able to see my screen. The whatever code we have discussed earlier, we have it in my notebook, and I see a lot of questions. I think this walkthrough should be able to clear it. I'm gonna import the libraries. These all are open source, so you can get that very easily. I'm gonna load my environment variables, and then let's go one by one. So getting the vector chunks, we have already like defined this. We are opening, we are getting the document. The document is nothing but a Swiss airline FAQ. We are getting the document, we are converting it into a chunk of documents, and then we are converting into embeddings. We are getting the relevant documents and we are answering the query. These methods we have already walked through, so I'm gonna quickly define these methods. After that, this is the perform web search. We have also gone through it, so I'm gonna quickly define it as well. And now it's time to see what our agentic workflow does. So the first query is, should I reconfirm my flight? Now this query looks very familiar to what you can expect an answer from a FAQ of an airline. So if I go ahead and if I run it, I'll get some relevant doc along with their similarity score. And if I see here, I'm also printing the similarity score so that we can see that what documents we got and what was their similarity score. And we also gone through this code base in the previous slide, which uh, depending upon the threshold, it tells whether to perform a web search or getting the answer from the RAG pipeline. So if I run it, you can see there are some scores here, and you can clearly see that the scores are above 30%. The score is 0.43, meaning 43%, 39%, 35%, and 33%, and 32%. So all the we got 5 documents, and the similarity score of all those documents was above 30%, meaning that we can get this answer from our RAG. And we gave this question to our to the large language model along with the relevant documents, and there we got the answer that no, reconfirmation of Swiss flight is not required. So this was present in our vector database in the FAQ guideline document, and I was able to, the large language model was able to answer that. This is good. Now let's go another way. I'm gonna comment this out, and I'm gonna comment out another query, which is how to make an Italian pizza. Now this is a kind of question which you can never expect an airline FAQ doc to answer. So I can go ahead and I can run it. I will get some relevant documents, and now if I go ahead and I run it, I will again see the document with the similarity score, but this time this is very low. This is 15%, 12%, 12%, and 10%. And then there is 9% as well. So it means that there is no relevant document because all of them have a lower threshold below 30%. So my agentic workflow says no relevant documents found with the sufficient similarity score. So it went ahead and it performed a web search, right? And from the web search, it got the answer. To make an Italian pizza, use a simple dough of flour, water, yeast, and salt. Bake them with tomato sauce and mozzarella. For a crispy crust, cook it in a hot oven. In a very summarized way, it is trying to answer my question. I can get a more detailed answer as from the search result as well, depending upon my configuration. So I hope this entire workflow was clear to you. And Vaishnavi asked the question of score threshold. I think you must be able to understand how you are getting the threshold and what the threshold actually means and how they actually work here. So this is what I wanted to show as a part of this code walkthrough. I'm gonna again minimize it, and I'm gonna go ahead and share my tab back. Okay, cool. So we are back on the slides. This was it. If there is any question related to this agentic workflow and whatever we have talked about, feel free to put that in the chat. And meanwhile, we're gonna go ahead and we'll go through more of the things. Okay, awesome. So let's talk more about this Gen AI and agentic workflow stuff. Okay, cool. Yeah, looking at this, I have some quotes from influential people and CEOs of big companies. And if the CEOs of Google, Microsoft, and OpenAI says that this is the next industrial revolution, then the question isn't should you learn Gen AI, it's when, and the answer is yesterday. So ideally, you should already have started it, but if you haven't, you should start it right away. And this is the reality of becoming an AI engineer. And let's talk real for a minute. So many of you are inspired, and that's great, but let's not sugarcoat what lies ahead if you choose to do this alone. Here is the brutal truth: even motivated developers drop off because they are just overwhelmed. And they don't fail because they are lazy, they fail because they have no map, just scattered landmarks. And let's be honest, building a Gen AI system isn't just about writing prompts anymore. You need to know which tool to use, when and why, the way we saw in our agentic workflow demo. You need working pipeline from data input to the agent output, the way we did here. And most importantly, you need real feedback when you build. And that's where most people quit. But the ones who don't, they either find mentorship or structured learning. And that's where advanced certification in Gen AI and multi-agent system by Coding Ninjas comes into the picture. So I'm gonna go ahead and I'm gonna share what you can expect in the Coding Ninjas program here, which I shared earlier in the start of the session as well. And I'm going to quickly share the form as well, which you can fill if you are interested in the program. And yeah, okay, you can fill it. And you'll also get a chance to connect one on one with the Coding Ninjas experts for a personalized roadmap. And everything you just saw today maps to the module in our program. So if you're serious about making this your career direction, don't try to wing it alone. Follow a proven roadmap. And this is the structured part which you won't find on YouTube. And this is what lies in the Coding Ninjas certification program, right? This is what you will be building overall. Okay. And this is the structured path which I'm going to showcase here. And a lot of people are asking for, I guess, this code base link. I think this is the one. You can find this in the rack search IPYNB notebook file. So I'm gonna share it here and feel free to refer that for the demo which we had in this session. And yes, this was it. And I'm gonna open for live Q&A, and I think there is not a lot of questions, but one, also we return a static response if the threshold doesn't mean we don't perform a web search. What might be the reason for this? Okay. I'm not able to understand the question very correctly, but you're saying that we return a static response if the threshold. That is not correct actually. If you went through the code base, we are not returning any static response. There are two cases. If you got a document above the threshold, then we are using those documents for the large language model to answer. But if we didn't get any document, above the threshold score, then we are using the web search to answer. Okay, and now I can see a lot of questions regarding the bootcamp, the GenAI program. So I'm gonna go ahead and ask the coding ninjas mentor to, or the program experts to chime in. And yeah,
Mm,
thank you for the session.
Sure. So first of all, thank you so much, Saurav Prateek, for such an insightful and such an informative session taken. So to all the participants, this was it from Saurav's end for the masterclass today. Before winding up the session, guys, I'll be just walking you through the overview of what we are actually providing, being the part of this program. So, if we talk about this program, this will be a 6 months live program wherein one will be learning to build real world Gen AI and multi agent apps using Python. You'll be having 10 plus hands-on projects to work upon your skill sets, to test your skill sets, to sharpen your skill sets, to practically implement those skill sets, whatever you have learned being the part of this program. We'll be helping you with mentors, feedback regarding your career guidance, how exactly should be the roadmap that you should follow in order to be successful, in order to grow into the domain. You'll be having job portal access of NSDC to help you out with a job hunt as well, and you'll be the part of an exclusive 10x developers club. See, being the part of such a great community helps you out to get the best out of your skill sets, out of your learnings. So definitely it will be helping you in the best way possible. You will be able to build really good connections and get the best out of yourself. And then after upskilling through this program, you'll be ideal to hunt for the job roles like GenAI engineer, prompt engineer, MS developer, and so on. Like multiple fields are there to explore in generative AI. So this was it, guys. Once again, I was just here to give you an overview of what we are actually helping you out with. If you want to deep dive more into it, if you want to know more about it, if you want to know if this goes well with what you are actually planning or not, we have shared in the form. The form was shared by Saurav Prateek, and I'm again sharing the form link in the chat box. Okay, I've shared it once again. You just have to click on the link, fill in your basic details, and then you will get a chance to get in connect with our experts one-on-one for a personalized roadmap so that you can deep dive into it. You can search about it, you can know about it, and you can decide if this is a perfect fit for you or not. And then after, and that again, that will be a one-on-one conversation, so you'll be able to clear all your doubts and queries as well. Since you all have been attending this masterclass from past 1 hour, we would not want like anyone you to go with any kinds of doubts and queries. So we'll be helping you with all your doubts and queries as well. And then if it seems like this is a perfect fit for you, we'll be helping you out to get enrolled in our program as well. So for that reason, I'll be waiting for another 1 minute. You already have the link in the chat box. Click on the link, fill in your basic details, and then we'll be connecting you as soon as possible, guys. So another 1 minute, and then I'll be winding up the session for today. Okay. So once again, thank you so much for your lovely participation, each and everyone. We hope to see every one of you in our upcoming program. Till then, best of luck, guys. Just one last thing, if you have not filled in the form and still want to know more about it, you can revisit our website. You can request for a callback from there. We'll get in touch with you and we'll be helping you in the best way possible. Once again, thank you so much. Best of luck. The masterclass is over.